bending and stages of loading, there are two stages. First is we have the uncracked stage, wherein your actual moment is less than the cracking moment. Therefore, the actual stresses also is less than the modulus of your rupture. So small loading does not produce tensile cracking. So at this stage, the concrete resists both tension and compression linearly, elastically with minimal tension in a steel. So let's say, for example, we have a beam. Pag niloadan natin yan, when we take a load on this beam, so this beam will bend. So magbe-bend yung beam natin. Yan. Until a certain portion wherein the tension side of the beam, dito sa bandang dulo ng beam, it starts to crack. Kung hindi pa nag-crack itong part na ito, that is what we call the uncracked stage. So there is a certain moment or what we call the cracking moment wherein kayang-kaya pang humawak ng concrete ng tension and compression. That's what we call the uncracked stage. So kumbaga buo pa rin siya. So ito yung reinforced concrete mo and then may bakal sa baba. Yan. So hindi pa nag-crack. Meron naman yung tendency na nasobrahan na siya. Nagka-crack na yung sa baba. So nakikita na yung bakal, kumbaga. Yung reinforcement dito sa part nito. This is the reinforcement. Yan. So at this stage, kapag buo pa yung concrete or the RC, that's what we call the uncracked stage. And at this stage, kung saan magka-crack na yung tension side mo, ito naman yung ating crack stage, wherein ang humahawak na lang dun sa tension side ng beam is itong bakal. Ito na lang ang humahawak dun sa tension side. Kasi wala nang humahawak, nag-crack na yun sa bandang baba, yung bottom fiber ng beam natin. So if this is the case, if the case is uncracked stage, ibig sabihin, kaya pang humawak ng concrete ng tension side. So we have three stresses in your uncracked stage. So we have your concrete stress in compression. Let's call it as F sub CC. Also the concrete stress in tension, or let's call it as F sub CT. And your steel stress, or F sub S. So ito yung gagamitin nating names for the stresses in your uncracked stage. So for example, we have a rectangular beam with a dimension of B times H. And steel, let's say the area of steel is A sub S. If the beam is loaded ng pababa, so if this is your beam and then it is loaded, this is the support. If this is the beam and it is loaded downward, the beam tends to have a positive moment. So nagkakaroon siya ng positive moment dito. So it produces a positive moment. Yan. And if we transform it into a transform section, let's say this is the neutral axis of your beam, and the neutral axis distance to the top fiber, let's say that is X. So meron tayong extreme concrete tensile fiber sa baba. And yun nga, kung na-convert na natin into your transformed section, the AS or the area of steel will now become N-1 multiplied by your AS from your theory of structure. And if this is the case, the neutral axis ito yung axis kung saan yung concrete the compression and the tension tends to separate. Ito yung pinaka neutral axis niya. So kumbaga sa top portion is we have the compression side, and the bottom portion of your NA or the neutral axis will be in tension side. So lahat ng mga stresses na nag-a-act sa yung beam, we have the compression at the top. So that is C sub C, or the compression stress brought by your concrete. And sa baba naman, we have dalawa ang humahawak. Kasi uncrack pa yung beam mo, ibig sabihin, hindi pa crack yung nasa baba or top, at the bottom fiber. Therefore, meron pa ring tension na hinahawakan yung concrete mo. That is T sub C. And meron ding hahawakan yung steel mong tension. So that is T sub S. And this is your compression brought by your concrete. And if these are the forces, so kukunin natin ngayon yung mga formulas for the uncracked stage from the transform. So NA, then X. This is your top fiber. And the distance from the top fiber up to the steel is, let's say that is D. So this is your top fiber. Taking moment about the top fiber. So dito tayo magmo-moment sa top fiber. So kunin natin ngayon yung value of X. So to solve for X, we have to take moment about the top fiber. So this is your A total multiplied by the X. And then the area multiplied by your moment arm plus the area of steel multiplied by the moment arm of the steel. So isa-isahin natin. Let's say the total area, that is area of concrete, that is B times H. And then area of steel in transform section is we have N minus 1 AS. So this is the area of concrete. This is the area of steel. So together, itong part na ito is we have the area total. Yung part na yan. Multiplied by its moment arm from the top fiber para makuha natin yung NA. So multiplied by X equals the area of concrete, that is BH, multiplied by the moment arm from the top fiber, that is H over 2. And then plus area of steel multiplied by the moment arm of steel from the top fiber. So we can solve X in this equation. And then another one from the transform section din, isosolve din natin yung moment of inertia about the neutral axis. Pag nasolve na natin yung X, we have to transform the section into the neutral axis or the moment of inertia about the neutral axis. How do we do that? So from the formula or the general formula, that is I, ita-transform natin yung dati niyang I or the moment of inertia plus the area multiplied by the distance or the moment arm from the neutral axis squared. Yan. Let's say, for example, this is the moment of inertia of the original concrete. So that is 112 BH cubed plus the area of concrete, that is B times H, multiplied by the moment arm from the neutral axis. So that is H over 2. Itong part na ito, dito yung centroid ng concrete. From the neutral axis, this is the distance. So ano daw ito? Itong distance na ito. So this is X minus H minus over 2 squared. So that is the distance from the neutral axis. Then plus the I of the steel. But the I of steel in the transform section has no moment of inertia, it is I only or 0. Nagiging 0 ito. Kasi transform na natin yung area of steel mo. So ang magiging formula na lang niya is we have the area of the steel multiplied by the distance of the steel from the neutral axis. So ano daw ito? Itong neutral axis to the steel. So this is D minus, so squared. So that is the moment of inertia about the neutral axis. After that, you can now solve for the concrete stress in compression. Ano ito magbura dito? Magbura. So that will be the formulas for your uncracked stage from the transform. So first you got to find for the X or the distance from the top fiber up to the neutral axis. Pag nalaman mo na yon, you can solve for the INA or I sub NA or the moment of inertia about the neutral axis. And then from that, using this formula, that is F sub CC is equals to the moment multiplied by X all over INA. The concrete stress in tension, that is F sub CT is equals to moment times X minus H all over NA. And steel stress is F sub S equals NM multiplied by D minus X all over INA. So these are your formulas for the uncracked stage. For the crack stage, wherein the actual moment, so yung actual moment niya is greater than the cracking moment. And your actual stress is greater than the modulus of rupture. So this is the crack stage. So again, if this is the beam and we load it, this beam tends to bend up to a certain time na magka-crack yung ilalim, yung bottom fiber. Kasi itong bottom fiber is in tension. Mahina ang concrete sa tension. So pag nag-crack na yung nasa bottom fiber mo, let's say this is the beam, exaggerated crack, and nakikita na yung bakal, ibig sabihin hindi niya na kayang humawak. Yung concrete mo hindi niya na kayang humawak ng tension side. So ang humahawak na lang ng tension side is we have the RSB. So sa taas, ang humahawak ng compression is the concrete. Ang humahawak ng tension is the steel. So yun na lang dalawa ang humahawak ng yung beam. So the stresses, nabawasan ka ng isa. We have concrete stress that is FC and steel stress that is F sub S. So yun ang pagkakaiba niya. If uncrack, meron tayong tatlong stresses, FC, FS, saka FCC, FT or FFST, and then we have the FCT or the compression concrete, the tension concrete, and the steel tension. So those are the three stresses. Whereas in your crack stresses or crack stage stresses, dalawa lang. Nawala na yung concrete tension kasi nag-crack na yung sa baba. So ang humahawak na lang ng compression is we have the concrete, and ang mahawak na lang ng tension is we have the steel. So again, let's say we have a beam with dimension BH and area of steel that is A sub S. So it now produces a moment, let's say that is M sub N. And let's say this is NA, so that is M sub N. So the transform section now becomes ganito. So nawala na yung area dun sa tension side ng concrete. So, above the NA that is in compression, wherein ang humahawak na lang sa compression mo is we have the concrete. And sa baba, we have the tension side. Ang humahawak na lang ng tension side is we have the steel. So again, taking moment about NA or the neutral axis. So that is summation MNA equals to B times X. So ito na lang, matitira. So this is B, and this is X. The moment arm, that is X over 2 about NA. So andito yung centroid. So this is X over 2. So kaya nakuha yung X over 2. That is equals to your area of steel, NAS. Then this is yung buong ito is D. So the moment arm is from NA to the steel. So ano daw yan? That is D minus X. So this is the moment arm about the neutral axis. And for solving for INA, that is 1/3 BX cubed plus NAS multiplied by D minus X squared. So mas simple lang siya. And you can compute for your F sub C, that is equals to M multiplied by X over INA. And for steel stress, that is F sub S equals NM D minus X all over INA. So nawalan lang siya ng isang component or isang stress. Question so far? So wala naman. So let's proceed. Other formulas that you can use on this problem. So that is modular ratio N, that is equals to the steel, what we call this, the E of steel or the modulus of elasticity all over the modulus of elasticity of your concrete. For flexural stress, ito naman is yung pinaka-basic na formula naman na to. So MC over I. Again, modulus of fracture, MC over I. Ang nagkaibahan niya lang dito is we have the moment na ginagamit. So when we talk about modulus of fracture, syempre, you use the moment or the cracking moment. For the flexural stress, that is the actual. That is M actual. So yeah. For the NSDP, meron tayong provision. You can use this if the FC prime is given or the compressive strength of concrete is given. The effective depth, yan. So that is given also by the NSCP, wherein CC is the concrete cover. So yan. So let's take sample problem. So determine the properties of the transformed section and calculate the elastic stresses of the given beam. If M equals 30 kilonewton meter or moment, letter B is 70 kilonewton meter. Use FC prime equals 21 MPa and effective depth of 425. So effective depth na is 425 mm. When we say effective depth, that is inalis natin yung concrete cover. So, andito kasi yung concrete cover na part nito. And it is reinforced by 3 pieces 32 mm diameter bar. So, the dimension of your beam is 300 mm by 500 mm. So, our solution, first we have to compute the cracking moment para malaman natin kung crack or uncrack. Compute X and then compute for NA and then you can solve for the stresses. So if uncrack, yung tatlo. If crack, yung dalawa. So parehas lang naman. Same, ang naibahan lang is the actual moment. So first, kung compute for the cracking moment, formula. So that is F cracking, M cracking, CT, IG, ano pa? FR equals 0.62 square root of FC prime. Diba? So we can equate MCR CT over IG equals to your 0.62 square root of FC prime. This is the general formula and this is the formula given by the NSCP. So our mga given. So cracking moment, what is CT? That is the height divided by 2. So 500 divided by 2 over 300 multiplied by 500 cube. So this is 112 BD cube. Tama? In your, what we call this, analytical geometry, the moment of inertia of a rectangle is 112 BD cube. That is equals to 0.62 square root of 21 MPa. So your cracking moment is equals to 35.52 kilonewton meter. Tama ba? Can you confirm? Kindly check kung tama. Before we proceed, 1 minute. Kindly check kung tama. Rejalin, is it correct?
Sir, wait lang.
Okay, sige. Pag-check na lang. Rejalin? Tama ba? Anyone from the group kung sino naka-compute? Denzel, Galapon. Okay, so Denzel, after that, what is our next step again? After computing for the cracking moment, step 2. What is our step 2? So determine if crack or uncrack. So what is again the moment actual or actual moment? Kanina? What is the actual moment? Kalimutan ko na rin. Yung cracking moment kanina, that is 30 kilonewton meter. So 30 kilonewton meter. So that is MA, MCR. Anong mas malaki? MCR. Tama? So what is it? Jason Lee, makadangdang. Is it crack or uncrack? Jason Lee? Wala, absent. Jenny Galasinaw.
Uncrack po.
Uncrack. Okay, so uncrack. So if uncrack again, ano ulit kapag uncrack, what are the stresses? Kain Angel Almazan. What are again the stresses if it is uncrack? Wala, absent din. Even though you are present, if you have no recitation, you will be marked absent. Laarni Perez.
Sir, ano po ulit yung question po?
Kung uncrack, what are again the stresses na kailangan nating isolve? So clue, if this is your beam, and then if it is uncracked, ibig sabihin, buo pa rin yung nasa baba. So ano yung mga stresses again?
Kwan po, sir. Concrete stress in compression.
So complete in compression sa taas.
Opo,
Then,
tapos
ano pa?
concrete stress in tension. And
Concrete
steel
in
stress po.
tension and
Opo, tapos steel stress
steel
po.
in tension. So buo pa kasi, ibig sabihin, kaya pa niyang humawak ng tension yung sa baba. Parang kumbaga no Ilocano ko haanak pa na perdi, makaigamnak pa iti tension, kung na di concrete di baba. So ibig sabihin, itong part na ito, hahawakan niya yung compression o kanya, bagi ka di compressionin, kung na. Sa baba naman, bagi ka di compressionin, ay di tension, sabi ng baba. Eh sabi ng steel, sige tutulong ako sa tension, parang ganoon. Pero kung crack na siya, ibig sabihin, naputol na ito, wala nang kwenta itong nasa baba. Ibig sabihin, ang umahawak na lang ng tension is the steel. So that is the difference between the crack and your uncracked section. So let's continue. After that, if we have already solved for MCR and we identified if it is crack or uncrack, what is our next step? Layan o dasko? Ano na ulit gagawin natin? Layan o dasko? Wala din. Christian Joy Costales.
Sir?
What is again our next step after we have identified if it is crack or uncrack? So na-identify na natin. Sabi natin uncrack.
Compute for X, sir.
Compute for X. That is
X,
the distance from the top fiber up to the neutral axis.
Neutral axis, sir.
If this is your beam, And let's assume that ito yung A. Pero hindi natin alam kung saan yung A. So this is your X. This is the still. This distance is the effective depth. Yan. So first we have to compute also ano pa yung mga given. Itong third part kasi nila so you have to transform into n minus 1 multiplied by s. Alam na natin yung s hindi natin alam yung n. And n is the modular ratio. Diba? So from your formula, the modular ratio is equals to E of S over V of concrete. Or ano pa bang formula based on kanina? We have E of S 4,700 square root of 55. So N was what is E of steel from your previous lesson. Alala nyo ba? Mark Vernon. What is E of steel? The modulus of elasticity of steel. Wala lang. About pressure sila na Pasqua. Pressure Pasqua.
Sir,
Maalala lang paano ang modulus of elasticity of steel or ES. Sumiligolol.
medyo na hindi ko ma-recall, sir, kasi mo ko last po.
Okay, sige. But remember this constant is important constant ay lang yung multiplied by 7685 multiplied by the effective depth 225. Answer? Calculator. 1 minute and then I will call for someone. So that is quantity 300 times 500 plus 9 minus 1, 768 pi multiplied by x, the unknown, that is equals to 300 times 500 times 500 over 2 plus 9 minus 1 times 768 pi times 425 or the effective depth. So x equals
Sir, 269.25.
269. Tama ba? Others. Please confirm sa others. So picturean nyo na lang para mabilis tayo. And then resolve it na lang sa inyong notebook para mabilis tayo. Other answer, okay naman? Wala namang iba? Nakuha lahat? Yes ba? 3. Pa-confirm. Pa-confirm kung saan dito yung totoo. Check nyo mabuti. Other? Check nyo mabuti. Baka magkamali tayo. So we have 2 answers na.
271 naman sa
271.
71.
Baka sa rounding. Hindi kasi ako nag-round dito sa Panayo. As you can see in AS, that is 768 pi. Hindi ako nag-round.
Sir, 269.95.
269.95. O, dalawa na ito. Ano pa? So, 2 points na si 269. Kayong nag-calculate nito. So, beware. Anyway, you can resolve naman later. So, let's say this is the answer. 269.95. So, that is your the value of x from the top fiber up to the neutral axis. So that is neutral axis. This is 269.95. This is your D. Yan. So next step is we have to move the moment of inertia about the neutral axis. And the moment of inertia about the neutral axis, that is equals to the summation of the original moment of inertia plus area times the distance from the centroid of the original area to the neutral axis squared, di ba? From your, what do you call this, physics ba to, or analytical geometry? So that is the summation of the original moment of inertia plus the area kung ano yung itatransform natin into the neutral axis multiplied by the distance of your centroid of the original area to the neutral axis. So what are the components for the concrete? Kasi dalawa ito eh. Meron yung concrete na area, meron din naman yung steel area. So that is equals to 112 BH cube plus BH multiplied by the distance of the centroid of your concrete. So saan ba ang centroid ng concrete? Sa gitna. Nandito yung h over 2. Sabi dyan is the distance from the centroid to the neutral axis. So ano daw ito? Ano yung part na yan? So how will you solve that? That is x minus h over 2. So this is the distance squared. So this is for concrete. Again, sa transformed ng steel, wala kasi siyang IG or moment of inertia. Kumbaga kinonvert natin siya as strip. So sa steel, we have only AD squared. So area of steel is n minus 1 multiplied by AS multiplied by the distance of the centroid. Ito lang naman ang centroid niya to the NA. So that is D minus X squared. So this is for steel. So this is for concrete. This is for steel. So yan. So substitute INA equals 112, 300, 500 cube plus 300, 500 times 269.95. Tama ba? 95 minus 500 divided by 2 squared. Yan. Yan. Plus 9 minus 1. So n minus 1. 768 pi multiplied by 425 minus 269.95 squared. So INA equals compute. Ren Sledge, Tayaban, do you have an answer already? Wala pa? How about the others? Trijalin. Dapat sanayin nyo nang mag-calculate ng mabilis ng ganyan kahaba. Wala pa?
Digits ba, sir?
Ilan?
Yung digits.
Sir, ang
You convert it in, what you call this, in scientific. Yung may 10 raised to, ganun. Sige. Other? Kasi maliit ito, mm to the fourth ito. So, most probably ito yon. Ganito yon. Nga ganyan yung answer.
Same, sir.
Same? Other? Wala ba nakakuha ng iba?
parehas lang.
Sige. So, kung wala namang iba, so ito na yung pan natin. Assume the answer. So, you recompute it again.
3.6.
3.65. Okay. Last, so we have to compute for the stresses. Pwede na tayong mag-compute for the stresses. That is for the compression brought by your concrete, M, X, I, and A. That is 30. Then be consistent. So this is in kilonewton meter. So tignan nyo mabuti, kilonewton meter ito. And your X is 269.95 mm. So this is meter, this is mm. So be careful with your conversion. And your INA is 3.65 multiplied by 10 raised to 9. This is mm to the fourth. That. So FCC equals, then for tension brought by your concrete, M, X, H minus X, INA, 30 kilonewton meter, 500 mm. 500 mm minus 269.95 divided by 3.65 multiplied by 10. FCP equals, and your FS is equals to NM. This is N, M, D minus X, I, and A. So this is equals to 9 times 30, 425, 425 minus 269.95 all over 3.65 multiplied by 10 raised to 9. So f of s equals answer. Exam San Agustin, FCC. Jenny Galasinao, FCP. Carl Kevin Soriano, FS. Again?
LFS po.
FS, ano?
1.15 times 10 raised to negative 5, sir.
1.15? 1.5?
Opo.
Times
Times 10 raised to negative 5.
negative 5. Ano ang kanya? Ang unit niya? Ano na lang ang natira? Newton, ano?
mm.
mm? Others? Yung iba? What are the answers? Pa-check ito. So, dapat hindi siya mm. This should be MPa. Baka nagkamali ka lang sa conversion. All stresses are in megapascal. Or megapascal is Newton per mm squared. So, i-convert nyo yung kilonewton into Newton, i-convert nyo yung meter into mm. Kasi naka-mm ito, naka-mm din yan. So, if this is Newton, this is mm, multiplied by mm, divided by mm to the fourth, makakancel yung dalawang mm. Tama? So, Newton per mm square na lang matitira. That is equals to
Megapascal.
So, i-check. Be careful with your conversion. Although, madali lang siya, direct substitution, but the conversion, very crucial yung conversion ninyo. So, to convert kilonewton to Newton, multiply nyo ng 1,000. Meter to mm, multiply nyo ulit ng 1,000. So, yung sa taas, dapat i-multiply mo siya ng 1 million para maging Newton mm. So, 30 times 269.95 times 1 million divided by 3.65 multiplied by 10 raised to 9. Any other answer? Other answer? Sana yung mga tinawag ko kanina. JZEM, San Agustin. What if FCC? Flory, Bacaro. Answer? Wala na itong mga to. Nag-leave na. Absent. Flory, Bacaro, absent. Princess Joy, Dulig. Wala na rin. Absent. Mark Vernon, Aragon. Wala na rin. Leanne Odasco. So I'm checking attendance na. Leanne Odasco. Mark Vincent, sarap yun. Mark Vincent. Wala na. Precious Pasqua.
Present, sir.
Anong answer? Any answer? You give answer or else you will be marked absent. Sarang na-compute mo dyan. So, mag-calculate lang. Wala. Princess Joy Dulig.
Sir, try ko po.
Yes, you try only. Basta may answer.
Sa FCT po, sir.
FCT, what is the answer?
1.89 times 10 raised to
1.89 times
10 po.
times 10.
Raised to 12 po.
12. Other? Rensledge, Tayaban.
Sir, sa FCC.
Yes.
2.44. Wait,
2.44.
44.
Yan lang? 2.44? Sige.
Ano?
Sige. On the 3, ang pinakamalapit is ito. So, dapat dito sa FCT, mukhang sa conversion, I think, you check if it is times 10 raised to 12. Check nyo lang yan. Dito kahit ito, you check if it is times 10 raised to negative 5. FCC is most probably, yan ang sagot, 2.44. So, you take picture before I remove the screen. So, any question or clarification? So, again, let's review. So, I will now erase the board. Let's review. So, again, there are two stages. We have the crack and uncrack. So, masasabi natin na uncrack if the cracking moment and the actual moment. So, what is the relationship? That must be less than. So, the actual moment is less than the cracking moment. If it is cracked, that is the actual moment is greater than the cracking moment. Again, if uncracked, so ibig sabihin, buo pa yung concrete mo. So, ibig sabihin, makakatulong pa si bottom fiber. So, meron tayong tatlo. That is CT, FCC, and FST. Pero kung nag-crack na siya, ibig sabihin, basag na yung nasa baba, hindi na makakatulong yung bottom fiber. So, we have two stresses, that is FC and the FS. So, yun ang pagkakaiba ng crack and uncrack. Again, what are the steps? So, first, solve for MCR. Second, determine if crack or uncrack. Third, solve for the X so that we can know the location of neutral axis. Fourth, you convert your IG into the transformed moment of inertia about neutral axis. Fifth, you can solve now for the stresses. Because you cannot solve the stresses, this is F equals, the general formula is MC over I. Your I must be in NA, and M is the actual. And C is the distance from INA to the fiber. So any question, clarification before we end the session? Question or clarification? Is it clear? Kind Angel Almazan?
So far, wala naman po, sir.
Okay naman. So we will continue next meeting with letter B. Try din natin kung the moment will be increased. So kanina is we have 30 kilonewton per 30 kilonewton meter. And then we will try also dagdagan natin yung load, pabigatin natin yung beam hanggang sa mag 70 kilonewton meter yung actual moment. So ano kaya ang mangyayari? Uncrack pa rin ba or the moment or the what they call this, the section of the beam starts to crack? So if you have no questions, so that's it for today or for tonight, and see you on next meeting. Bukas is walang Zoom. So next meeting na lang tayo, either Friday siguro. So have a nice evening to everyone.
Bye, sir.